Okay, 10.4, inscribed angles, two new vocabulary, inscribed angle and intercept arc. An inscribed angle, if you're looking at the diagram, would be P because it's where two chords meet. And then the intersecting arc will be the arc that's associated with it going in whatever direction the question asks. Okay, so as you can see here from the diagrams of inscribed angles, there are three different types. There are one where the inscribed angle, the line goes actually through the center, where the center is actually inside the inscribed angle. Don't forget this is the inscribed angle. Okay, and then this one is the center where it's on the outside. So in other words, the center is no part of the inscribed angle. Three different cases, you'll get to use all three of them. Alright, so here's the theorem, and the theorem is just purely and simply whatever this arc is between A and B. Angle 1 is half of the degrees. So if AB, let's just say it's 100 degrees, then the angle question number 1 will actually, angle number 1 will actually be 50 degrees. So here's example 1, and as you can see, we're looking for the measure of angle P, in other words, which is this angle here. You know the angle is half, the inscribed angle is half of the arc. Well, if the arc is 70 degrees, the inside angle is 35. Doing the reverse of that, if angle N is 56 degrees, then the arc PO must be 112. So let's just have a quick look at question number 1, example 1. If the arc AC is 60 degrees, then angle ABC is half of that, so this guy will be 30 degrees. Alright, question 2 is doing the opposite. If the angle RST is 63 degrees, then arc sector RT must be twice that, which is 126 degrees. Alright, so here's example 2, finding the angle measures. Look at the statement. The statement tells you that the two angles are congruent. We're using algebra again, so obviously they must both equal each other. So put them equal to each other, substitute them in, solve for x, and then plug it back in again. Alright, and again, you know me, don't just plug it into one, plug it into both. So 3x, 3 times 20 minus 5 by the example is 55 degrees. 55 degrees, didn't do that very well. Alright, so this is 55 degrees. And then 2 times 20 plus the 15 is also 55 degrees. Okay, so if you get the same answer, your algebra is correct. Right, so from example 2, we're now on question 5. We know that the two inscribed angles equal each other, so 2x minus 54 it must equal the x. Alright, add 54 to both sides, so 2x equals x plus 54. Subtract x from both sides, so x equals 54. And you know by plugging it back in again, well, you know that that must equal 54. And 2 times 54, take away 54, is just going to come back to 54. So you know your algebra is correct. Alright, so example 3, we're doing 2-column proof, not done it for a while. You know the format now, start with what's been given. Okay, do we need to do as much of this as possible as we need? But no, we don't. But start thinking about information that you do know. You do know that your two inscribed angles are congruent. Alright, so we've got that. And if you look at what you do know here, they're both using this side or they're both using that side, so you finish up with your angle side. So take your time, work through each of these. Alright, so now we're looking at angles in polygons, and the first one we're going to look at is a semicircle. So angle or line FH is actually a semicircle, FGH is a semicircle, or FJH is a semicircle, which you know is 180 degrees. Okay, well, by definition, if your arc is 180 degrees, your angle, which is G, must be 90 degrees, all right? But it's a special property, and every time you've got a line that's a diameter, your inscribed angle will always be 90 degrees. So here's example 4, and what did they do in example 4? Well, first of all, you know that FJH is a semicircle, which means that angle G must be 90 degrees, so angle GFH and GHF must also equal 90 degrees. Alright, well they're actually putting in 90 degrees in there. You don't have to, but if you want you can do it exactly the same as they've done. Or at this point, this line here, you can ignore that 90 degrees there and change that to 90 degrees and you'll still get the same answer. But again, don't like the way they've done it. They only put it into one angle. Plug it back into the other and add them together to make sure you've got the correct total. Alright, so let's have a look at question number 8. You know that your 3x plus 1 angle plus 7x minus 1 must equal 90 degrees. Those two angles must be 90 because Q is 90, so add them together. So 10x must equal 90, so x is going to equal 9. Okay, plug it back in again. 3 times 9 is 27, plus the 1 is 28. Okay, and 7 nines is 63, take away 1 is 62. And if you add these two guys together, you indeed do get 90, so you know your algebra is correct. So angle R, which is what we want, must be 62 degrees. Make sure you answer the question.